Welcome to QHSE Talks, where we dive into the challenges shaping our planet and explore the solutions that can help protect our future. Today, we're taking a closer look at global environmental issues, the problems that affect every living being on Earth. From polluted air and contaminated water to deforestation and climate change, our environment is facing growing pressure from human activity. Understanding these issues starts with understanding the environment itself, what it is, and why it matters to all of us.
Absolutely. And to do that, we probably need to start on the same page. Like, what do we mean by environment here?
Good point.
The sources define it pretty broadly. Basically, everything in the world around us that surrounds and affects life. So the air, water, soil, plants, animals, all those interconnected systems.
Right, the whole picture.
Exactly.
And what's really striking from the sources is how our relationship with that environment has changed so dramatically.
Oh, completely.
For thousands of years, the view was, well, that nature's riches were limitless, right? People lived more or less in harmony, thinking resources were just endless.
That was the perception, yeah. Because human impact was relatively small compared to the planet's scale.
But that's obviously not the case anymore.
Not at all. With civilization's growth, especially, industrialization, technology, our interference just exploded.
Right.
The sources paint a really stark picture. We hit this point where our impact grew exponentially. And now the reality is, frankly, our ecology becomes worse and worse with every new day. That's a direct quote from one of the sources.
Wow. Yeah. We're not just living in nature anymore. We're kind of shaping it, aren't we? For better or worse.
We're the dominant force now, yeah, geologically speaking.
Okay, so that really sets the stage for our deep dive. We're going to structure this around the main issues our sources highlight. We'll start kind of local air, water, and soil pollution. Then we'll look up at the atmosphere acid rain, ozone depletion, and we really need to unpack the difference between global warming and climate change.
That's a key distinction.
Definitely. And finally, we'll look at land degradation, deforestation, and the scary topic of biodiversity loss.
Sounds like a plan. It's basically the essential knowledge stack you need to understand these interconnected crises.
Exactly. So where should we start? Maybe with the air we breathe?
Let's jump right in. Air pollution feels like the most immediate for many people.
Okay, air pollution. The sources call it a community problem, which makes sense. You see the smog, you feel it. So who are the biggest culprits here? What's putting this stuff in the air?
Well, the sources point pretty clearly to transportation first. Cars, trucks, buses, airplanes. They're huge contributors. They release all these partly burned gases, particulates, right into the lower atmosphere where we live and breathe.
Right, the exhaust fumes we see every day.
Exactly. But it's not just things that move. We also have the fixed sources factories, power plants. They pump out smoke and gases too, often concentrated in certain areas.
So you've got all these pollutants, carbon monoxide, sulfur dioxide, nitrogen oxides, plus just soot and dust going into the air. But they don't just disappear, right? How does that turn into the smog we see hanging over cities?
It's a combination of things. These pollutants, dirt, smoke, gases get picked up by wind and air currents. They could travel pretty far, actually.
Okay.
Then, especially under certain weather conditions, like sunlight reacting with nitrogen oxides and VOC's volatile organic compounds, you get photochemical smog.
Ah, so sunlight is part of the recipe.
It is. And sometimes, particularly in valleys or when you have what's called a thermal inversion, where warmer air traps cooler, polluted air near the ground, these pollutants get concentrated. They just sit there like a blanket over the city.
A blanket of smog, yeah. So it's a local problem, but the sources might be regional or even further away.
Precisely. It highlights how interconnected air quality is.
Okay, let's move down from the air to water pollution. The obvious cause is dumping waste directly into rivers and lakes, right?
That's definitely a major source, yeah. Industrial discharge, sewage.
But the sources also talk a lot about agriculture. How does farming pollute water? It seems less direct.
It is less direct, which makes it harder to manage sometimes. This is what's called non-point source pollution. It's not coming from a single pipe.
Okay.
Harmful wastes, mainly chemicals, get into the soil first. Think about fields sprayed with pesticides.
And pesticides, just to be clear, the sources define these as chemicals used to kill insects and weeds, right? Not just on huge farms, but in cities too.
Exactly. Parks, gardens, farms, they're used widely. And while the aim is to kill pests or weeds,
right,
when it rains heavily, these chemicals, along with excess fertilizers, nitrogen, phosphorus, get washed off the fields and drain into streams, rivers, lakes, even groundwater.
Ah, the runoff.
Yes, the runoff is huge. It causes all sorts of problems like eutrophication, those big algal blooms that choke the oxygen out of the water, and it puts toxic chemicals directly into our water sources.
And the health impact.
It's serious. The sources are very clear.
Yeah.
Polluted water is a major way diseases spread. Things like cholera, typhoid. It's the direct link from chemical contamination to public health crises.
Okay, air, water. Now let's talk about the ground itself. Soil. The sources flag soil pollution and degradation as a global threat. They mention it's particularly bad in places like North Africa, citing the FAO. Why is soil degradation such a big deal, maybe compared to air pollution, which feels more immediate?
Well, air pollution hits you quickly, yes.
Yeah.
But soil degradation, that's maybe slower, but it's deeply existential. The scale is enormous. The FAO, that's the UN's Food and Agriculture Organization, says that about 1/3 of the world's soil is already degraded.
1/3. Wow.
Yeah. Intense and moderate degradation. We're talking about erosion, loss of nutrients, compaction, contamination with salts or chemicals, basically destroying the soil's ability to grow things.
And since most of our food comes from soil.
Exactly. Something like 95% of our food comes directly or indirectly from soil. So degrading it fundamentally threatens global food security. It's a slow-motion crisis with potentially devastating consequences.
Okay, I need to pause you there because this next fact from the sources, it really stopped me in my tracks. It changes how you think about recovery. It says it takes 1,000 years to naturally create just 1 centimeter of good arable topsoil.
That fact.
Yeah.
Yeah, it's absolutely critical. When you grasp that time scale, a millennium, for 1 centimeter of the thin layer that supports civilization, it puts all our current destructive practices into a completely different perspective.
I mean, 1,000 years.
We can lose that centimeter or more in a single bad farming season or due to severe erosion after deforestation. It means soil loss isn't just damage on human timescales, it's essentially permanent.
So when you say 1/3 of the world's soil is already degraded, that's potentially centuries, millennia of natural formation just gone.
Effectively, yes. It underscores why protecting the soil we still have is so incredibly vital. It's not a resource we can just manufacture or quickly replace. That 1,000-year detail really drives home the severity and the irreversibility, in human terms, of the problem. Okay, so moving up from the ground, let's look back at the atmosphere, but focusing now on some of the bigger chemical issues happening up there. First up, acid rain.
Right. Acid rain. I remember hearing a lot about this maybe a few decades ago. It shows how pollution doesn't respect borders, right? How does it actually form?
It starts with emissions, primarily sulfur dioxide,
Yeah.
SO2, and nitrogen oxides, AIs.
Oh.
These are poisonous gases that come mainly from burning fossil fuels in power stations and from vehicle exhausts.
Okay, so they go up into the air.
And once they're up there, they mix with oxygen, water vapor, other chemicals in the atmosphere. They undergo chemical reactions and transform it into sulfuric acid and nitric acid.
Actual acids.
Yes, tiny droplets of acid. These then fall back to Earth, not just as rain, but also as snow, fog, or even dry acidic particles.
And the impact when it lands, is it immediate?
Oh, yes. It can be devastating. It poisons lakes and rivers, killing fish and other aquatic life because it lowers the pH of the water drastically.
Right.
It damages forests, harms trees by damaging leaves and leaching nutrients from the soil. And it even corrodes buildings and statues. Anything made of limestone or metal, it literally eats away at things.
But unlike, say, climate change, which feels so huge and complex, the sources seem to suggest acid rain is a problem we actually know how to tackle. What are the fixes?
Because we know the main source is SO2 from power plants, NOx from vehicles, the solutions are pretty targeted. Things like fitting scrubbers to power station chimneys to remove the sulfur before it's released.
Okay.
And for vehicles, stricter emission standards, catalytic converters, things that reduce the nitrogen oxides coming out of the tailpipe. Switching to lower sulfur fuels also helps.
So it shows that if you identify the specific cause, you can engineer a solution.
It does. Acid rain levels have actually decreased significantly in North America and Europe because of these kinds of regulations. It's a qualified success story showing environmental controls can work.
Okay, so that's stuff coming down from the atmosphere. What about protecting what's up there? That brings us to the ozone layer. We hear about the hole in the ozone layer. What's its job, actually? Why is it so important?
The ozone layer is basically Earth's natural sunscreen. It sits way up in the stratosphere, and its main role is to absorb most of the sun's harmful, high-frequency ultraviolet radiation, specifically UVB and UVC.
Harmful how?
Well, without that filtering effect, that intense UV radiation would reach the surface and would be lethal to most life. It causes skin cancer, cataracts, damages DNA, harms plants. It's really nasty stuff. The ozone layer makes life on the surface possible.
And the problem is that this layer was getting thinner, creating these holes, especially over Antarctica. The sources pin the blame squarely on CFC's chlorofluorocarbons. Where did they come from?
CFCs were kind of miracle chemicals in the mid-20th century. They were stable, non-toxic, non-flammable, perfect for refrigerants like Freon in air conditioners and fridges, propellants in aerosol spray cans, and for making foam insulation.
So widely used stuff.
Incredibly widely used. The problem was their stability. They don't break down easily near the ground, so they drift slowly upwards, all the way to the stratosphere.
And then what happens?
Up there, the intense UV radiation finally breaks them apart, and that releases chlorine atoms.
And the chlorine is the bad guy here.
It's the really bad guy. A single chlorine atom acts like a catalyst. It can trigger a chain reaction that destroys tens of thousands of ozone molecules before it's eventually removed from the system.
Wow, one atom causes that much damage.
Yeah, it's incredibly efficient at destroying ozone. It basically rips apart the O3 molecules again and again.
Now, the sources do say that CFCs are largely banned now, thanks to things like the Montreal Protocol. That's good news, right?
It is good news. It's probably the biggest international environmental success story we have. The production and use of the worst ozone-depleting substances have been phased out globally.
But there's a but. There's always a but.
There is. The sources give a warning. First, CFCs last a long time in the atmosphere, so the ozone layer is still recovering and will take decades more to get back to pre-1980 levels.
Okay.
Second, we have to be careful about the chemicals used to replace CFCs. Some of them, like HCFCs and HFCs, might be less damaging to ozone, but they are potent greenhouse gases contributing to climate change.
Solving one problem can create another.
Exactly. So the warning is, we need sustained vigilance. If we don't keep this problem under control, those harmful UV rays could increase again with all the associated health and environmental risks.
Okay, this feels like a natural transition to the big one, global warming and climate change. These terms are often used interchangeably, but the sources insist on a distinction. Let's start with global warming. What is the specific definition here?
Right. Global warming, according to the sources, is specifically about the increase in the global average temperature near the Earth's surface. It's recent, it's ongoing, and crucially, it's attributed directly to the buildup of greenhouse gases in the atmosphere from human activities.
So warming equals average temperature rise due to GHGs caused by us.
Precisely. It's the warming component.
And the signs aren't just theoretical models. We see them, right?
Oh, yes. The sources list clear, observable signs. Rising land surface temperatures, rising ocean temperatures, which causes seawater to expand.
Thermal expansion, right?
Exactly. Plus melting glaciers and polar ice sheets. All of this contributes to rising sea levels.
Okay.
And the consequences cascade from there. More frequent and intense heat waves, changes in precipitation patterns leading to floods in some areas, droughts and desertification in others, even unusual snowmelts.
Okay, so that's global warming. How is climate change different then?
Climate change is the broader term. It refers to any significant long-term change in the state of the climate. That means changes in average weather patterns, temperature, precipitation, wind that persist for decades or longer.
So global warming is a major driver of climate change.
Exactly. Global warming, the increase in average temperature, is causing the climate to change in numerous ways.
And here's a nuance the sources mention. Even if the global average temperature goes up, some specific places might get colder or stay the same.
That's a really important point. Climate change isn't uniform. Warming oceans can alter currents, changing weather patterns dramatically. So yes, while the overall planet warms, some regions might experience colder winters or more rainfall, while others face extreme heat and drought. Climate change encompasses all these shifts, not just the warming part.
That makes sense. It's about the disruption of the whole system.
Precisely.
I like the suggestion in the sources to make this real. Ask an older person what the weather was like 30 years ago in your birthday month. Has it changed? That really brings it home.
It does. It connects the scientific data to lived experience, to shifting seasons, things people notice in their own lives.
And these changes aren't just about temperature or rain, right? The sources mention other consequences.
Yes. They can lead to other harmful effects. Things like changes in growing seasons, which impacts agriculture. And worryingly, the spread of diseases as insects and pathogens move into new areas that become warmer or wetter. Some sources use the term climate disruption to capture all these unwanted, unnatural changes.
Okay, let's quickly touch on the mechanism, the greenhouse effect. We don't need a deep dive into the physics, but what are the main gases involved, the GHGs?
Right, the greenhouse effect itself is natural and essential for life. Certain gases trap some of the Earth's outgoing infrared radiation, keeping the planet warm enough.
We're enhancing it.
We're enhancing it too much. The main culprits, the greenhouse gases listed, are carbon dioxide, that's CO2, the biggest one by volume from human activity, then methane, CH4, nitrous oxide, N2O, ozone, O3. But the ground level stuff acts as a GHG too. And then a bunch of industrial gases, CFCs, HCFCs, HFCs, PFCs, SF6.
That's quite a list. CO2 gets most of the attention, but you mentioned methane, CH4. How does that compare?
That's a key detail. CO2 is the most abundant, long-lived greenhouse gas we emit, mainly from burning fossil fuels, coal, oil, natural gas. It stays in the atmosphere for centuries, so it drives long-term warming.
Okay.
Methane, CH4, is much less abundant, but it's way more potent in the short term. Over, say, a 20-year period, it traps about 80 times more heat than CO2.
80 times.
Yeah, but it breaks down much faster. It only lasts about a decade or so in the atmosphere. So cutting methane emissions, which come from sources like livestock farming, rice paddies, natural gas leaks, could give us a quicker win in slowing down the rate of warming.
So CO2 is the long-haul problem. Methane is the short-term accelerator.
That's a good way to put it. We need to tackle both. But they have different timescales and require different strategies. The focus on CO2 from fossil fuels is because it locks in warming for generations. Okay. Let's shift focus back to the land itself, specifically how we're physically changing habitats.
This brings us to deforestation.
Right, the clearing of forests. The sources say they're disappearing because they're cut down or burned. The reasons given are pretty straightforward. Making way for buildings, factories, farms.
Those are factors, yes, especially for expanding settlements. But the really big economic drivers, particularly in tropical regions, are a bit different.
Okay, what are they?
You've got large-scale commercial logging for timber and paper. Then a huge one is converting forests to agricultural land. Not just small farms, but massive operations.
Like what?
Cattle ranching is a major driver, especially, say, in the Amazon basin. Forests are cleared, often burned, to create pasture land, which might only be fertile for a few years.
Right. And then there's the boom in commodity crops. Huge plantations for things like palm oil, soy, rubber. These require clearing vast areas of natural forest for monocultures.
So it's global demand for beef, palm oil, soy, timber that's really driving a lot of this.
To a very large extent, yes. These activities often involve burning, which not only destroys the habitat instantly, but also releases enormous amounts of stored carbon into the atmosphere, creating a direct feedback loop with climate change.
And the immediate consequence for the wildlife there.
It's often total annihilation for the species living in that specific patch of forest. When you replace a complex forest ecosystem with a palm oil plantation or a cattle pasture, the vast majority of the original plants and animals just disappear. They become extinct locally, and if it happens across their range, they become extinct globally.
Which leads us directly into the next crisis, the loss of biological diversity or biodiversity. The statistic in our sources here is just staggering.
It is horrifying. The rate of loss is way beyond anything natural. The sources state, every 10 minutes, one kind of animal, plant, or insect dies out forever.
Every 10 minutes?
Every 10 minutes. Think about that. By the time we finish this conversation, several species could be gone permanently.
It's hard to even comprehend. And the projection, if this continues...
The projection is that if these trends aren't halted, potentially 1 million species that are alive today could become extinct relatively soon.
1 million species. When we lose a species, what are we actually losing apart from, that specific creature or plant?
We're losing parts of the intricate web of life that supports us all. We lose ecosystem stability. Maybe we lose a pollinator essential for crops. Maybe we lose a predator that kept pests in check.
Okay.
We lose unique genetic information, potentially future medicines or resilient crop varieties that only exist in that one species. Biodiversity provides essential ecosystem services, things like water purification, soil creation, climate regulation. Losing species is like pulling threads from the tapestry eventually. The whole thing unravels.
It makes the call to action feel incredibly urgent. The sources specifically mention needing to save animals from Red Book. What is the Red Book?
That's a reference to the IUCN Red List of Threatened Species. IUCN is the International Union for Conservation of Nature.
Ah, okay.
The Red List is the most comprehensive global inventory of the conservation status of species. It identifies which plants, animals, fungi are vulnerable, endangered, critically endangered, or extinct in the wild. So saving animals from the Red Book means prioritizing conservation efforts for those species closest to the brink of disappearing forever. It's the planet's emergency watch list. So we've looked at a lot of the symptoms, the pollution, the warming, the extinctions, but the sources also point to some fundamental underlying drivers. The first one they identify as crucial is overpopulation.
Right. It sort of acts as a multiplier for all the other problems, doesn't it?
How is population reaching unsustainable levels, according to the sources?
It's fundamentally about resource demand and waste generation. The sheer number of people on the planet means we're consuming resources, water, fuel, food, minerals, faster than the Earth can naturally replenish them.
And simultaneously, we're producing waste pollution, greenhouse gases, faster than the environment can absorb or break it down. The sources state the population is reaching levels that strain resources, leading to shortages of essentials like water, fuel, and food in many areas.
And this pressure isn't evenly distributed across the world, is it?
No, it isn't. While per-person consumption is generally much higher in developed countries, meaning individuals there have a larger environmental footprint, the sources highlight that the rapid growth in population, particularly in less developing countries, puts immense pressure on already scarce local resources.
How so?
Well, it can lead to faster depletion of local water sources, more rapid conversion of forests or grasslands for subsistence farming, depletion of local firewood supplies. It puts a huge strain on the immediate environment and can exacerbate poverty and instability, even if the global impact per person is lower than in wealthy nations.
And this pressure to provide for everyone, especially food, linked back directly to agriculture, right? We need intensive agriculture, but that causes its own problems.
Exactly. It creates this difficult feedback loop. To feed billions of people, we often rely on intensive agricultural methods.
Which means?
Which means heavy use of chemical fertilizers to boost yields, pesticides, and insecticides to protect crops. And as we discussed earlier, these practices themselves damage the environment.
Right, the water pollution, the soil degradation.
Yes. The reliance on these chemicals, driven by the need to produce enough food for the current population, contributes significantly to water contamination, harms soil health long-term, and the production of these chemicals is often energy-intensive, adding to greenhouse gas emissions.
So we're trying to solve the food problem in a way that makes the resource base weaker over time. It feels like borrowing from the future.
That's a very apt way to put it. We're effectively trading long-term soil health, that 1,000-year per centimeter resource, and clean water for short-term yield maximization. It shows how population pressure and consumption patterns amplify nearly every environmental problem we've discussed.
Okay, it's easy to feel a bit, well, bleak after covering all that, the 1,000-year soil, species vanishing every 10 minutes. But the sources don't just leave it there. They do move into potential solutions, concrete actions. The problems are interconnected, so presumably the solutions need to be too.
Absolutely. There's no single silver bullet. The solutions have to tackle land use, energy, industry, waste, conservation, all at the same time. The sources list several key approaches.
All right, let's hear them. What's first?
Well, countering deforestation directly, planting trees and managing forests sustainably, reforestation and afforestation. It helps absorb CO2, restore habitats, protect soil.
Makes sense. What else?
A huge one is shifting our energy system, moving decisively to renewable energy sources like solar, wind, geothermal.
Right, getting off fossil fuels.
Exactly. That directly tackles the root cause of a large chunk of greenhouse gas emissions and also the pollutants that cause acid rain.
Yeah.
It means decarbonizing our electricity generation.
And what about industry and transport, beyond just the power source? The sources mention encouraging green industry and transportation. What does that look like practically?
Green industry is about rethinking production itself, moving towards a circular economy, designing products for durability, reuse, repair, recycling, minimizing waste, improving energy efficiency, using less toxic materials.
Okay, closing the loop.
Yeah. And for transportation, it means accelerating the shift away from internal combustion engines toward electric vehicles, yes, but also massively investing in efficient public transport, cycling infrastructure, making cities less car dependent, reducing vehicle emissions overall.
And for the biodiversity crisis, how do we actively help species?
Direct conservation action is crucial. The sources mention creating parks and protected areas for endangered animals.
Safe havens.
Essentially, yes. National parks, nature reserves, wildlife corridors, areas shielded from habitat destruction, hunting, or other pressures, allowing populations, especially those on the red list, a chance to recover.
Okay. And on a more individual or community level?
Recycling our wastes is highlighted. It seems simple, but it's important
Why exactly?
because it reduces the demand for extracting virgin resources. Less mining, logging, drilling, which have huge environmental impacts, and it means less waste going into landfills or incinerators, which cause soil, water, and air pollution. It helps close that material loop we talked about.
Right. And finally, what about the big corporate players, the factories, the enterprises?
The sources talk about persuading enterprises to stop polluting activities and to embrace something called responsible care.
Persuading. Does that work? What does responsible care mean?
Well, persuading might be the start, but often it needs regulatory backing or strong public pressure. Responsible care essentially means companies taking proactive responsibility for their environmental footprint throughout their entire operation by setting internal goals for reducing emissions, managing chemicals safely, minimizing waste, improving energy efficiency, being transparent about their environmental performance. It's about building environmental stewardship into the business model, not just complying with minimum regulations.
Yeah.
It pushes the onus onto companies to actively manage and reduce their impact. #tag outro.
So wrapping this up, it's been a huge amount to cover. We've gone from, the smog outside your window and the chemicals in your water right up to the ozone layer and the global shifts in climate.
Yeah, we really span the spectrum, and hopefully it reinforces that definition we started with. The environment is everything supporting life: the air, the water, the soil, the biodiversity. And the sources make it clear that pretty much every part of that system is under serious pressure right now.
And that pressure is largely from us, from human activity, amplified by population and consumption levels straining the planet's limits.
That's the core message running through all the sources, yeah.
And that timescale thing really sticks with me. That 1,000 years for 1 centimeter of soil. It just reframes everything and tells us recovery isn't quick, and some damage is effectively permanent on human timescales.
It forces you to think long term, yeah.
Yeah.
Which leads into that final thought from the sources, that sort of philosophical point. What goes around comes around.
Right. The old saying, how does that apply here?
Well, if our actions, pollution, deforestation, emissions are what's going around now, causing immediate harm and resource depletion, then the coming around part is the consequence. And because environmental recovery takes so long, centuries for forests, millennia for soil, decades for the ozone layer, the consequences of what we do today will be felt far, far into the future.
So the coming around isn't necessarily in our lifetime?
Not always, no.
Yeah.
The feedback loop is incredibly slow for some of these systems. It implies we're already experiencing the consequences of past actions. And what we do now determines the state of the planet for generations, hundreds, even thousands of years from now.
So the final thought for you, the listener, is maybe to weigh that. Our daily choices versus that 1,000-year recovery timeline. Are we acting in a way that considers the extremely long coming around phase of environmental consequence? Something to reflect on.